Hello friends, continuing with the chapter Charges and Fields of the unit Electrostatics. Today we start with fifth topic, electric flux. Before we develop the concept of electric flux, we need to understand what is an electric line of force. Let us define electric line of force. The path followed by a unit positive charge or a test charge in an electric field is defined as an electric line of force, or the curved imaginary lines tangent to which at any point on it determines direction of electric field at that point is defined as electric line of force. Here see, it's a curved line which is electric line of force, and we have drawn a tangent. This tangent gives us direction of electric field. Now we see electric lines of force due to a single isolated positive charge and negative point electric charge. So first, electric lines of force due to single isolated positive charge. These are electric lines of force due to single isolated positive charge, and these are electric lines of force due to single isolated negative charge. We see here lines of force are emerging out, and we see here lines of force are converging at negative point. I repeat, lines of force are emerging out of positive point electric charge, and lines of force are converging at negative point electric charge. Now number 3, here we see the electric lines of force due to an electric dipole. This is a pair of charges, positive and negative, separated by small distance, constituting an electric dipole. Okay, so the electric lines of force due to electric dipole are as shown. Similarly, electric lines of force due to two positive charges equal in magnitude, similar in nature, placed close to each other are as shown. So these are the 2 point electric charges which are separated, closely separated, and they are of same magnitude, and the electric lines of force are as shown. Next, electric lines of force due to two positive charges and a single charge separated by small distance are as shown. These are two positive point electric charges. This is single point electric charge. So the lines of force, you can carefully look at number of lines of force due to two positive charges and due to single charge. The lines of force are almost double than that due to single isolated positive point electric charge. So it means number of lines of force depends upon magnitude of the charge. Now number 6, electric lines of force due to uniformly charged thin insulated plane sheet are as shown. These lines of force are perpendicular to the surfaces, both surfaces of the plane sheet. The direction of electric field is perpendicular to the sheet. You have to mark it from the diagram itself. Now number 2, we look into characteristics of electric lines of force. Point by point we will look into. First point, we consider origin and termination of electric lines of force. Now, electric lines of force always originate from positive charge and terminate at negative charge. You can see at the diagrams, in all the diagrams that you have drawn previously, that all the electric lines of force are originating from positive charge and terminating at negative charge. Now number 2, continuity. Electric lines of force are continuous. Electric lines of force are continuous and never terminate in space. If they terminate in space, then there would be no electric field in that region. So you can look into the diagram. The lines of force are continuous and they don't terminate in space. They terminate always at negative charge, originate always from positive charge. Now number 3, number of lines of force. Now number of lines of force depends upon magnitude of charge. We have seen in the previous diagram that electric lines of force due to 2 positive point electric charges and single positive point electric charge. We have seen the numbers is double due to 2 point electric charges as compared to single point electric charge. So number of electric lines of force depends upon magnitude of the charge. Number 4, shape. Shape is curved and are imaginary. Electric lines of force are usually curved and are imaginary. Now elasticity. Electric lines of force behave as stretched elastic membranes. They undergo longitudinal contraction and lateral expansion. Now 6th point, tangent to line of force. We look at tangent to line of force. Now tangent to line of force at any point on it determines direction of electric field E at that point. Here it determines the direction of electric field. This arrow shows the direction of electric field at this point. Okay, so the tangent to line of force at any point on it determines direction of electric field E at that point. Now number 7, intersection. Two electric lines of force never intersect. If they intersect, then at the point of intersection, two tangents can be drawn which determine two different directions of electric field at the same point, that is at the point of intersection, which is not possible. Here you look at the diagram. Two electric lines of force are intersecting here at this point. Now if we draw tangent to the two electric lines of force, they are in the different directions. So here is the electric field, direction of electric fields due to this tangent, and here is direction of electric field due to this tangent. So at the same point there are two directions of electric field, which is not possible. Okay. Now closeness. Closeness of electric lines of force indicate strong field region, and largely spaced indicate weak field region. So this is all about electric lines of force. Now third point, mapping electric lines of force. Electric lines of force are mapped with the help of a unit positive charge and is the path followed by it in the electric field. Now look at the diagram. This is a positive point electric charge and it has a field around it. We place a test charge, unit positive charge, at somewhere, and we mark the point of its tail as well as of its tip, and we shift it to the another place. Again we mark the point of tail and tip, and then we shift this to again another point. We mark the point tail and tip, and again we shift to the other point. We mark the point tail and tip, and then we join all the tails and tip by dotted lines, and that dotted line will give us the electric line of force. This is how we map electric lines of force. Okay. Now, fourth point, what are advantages of mapping electric lines of force? Advantages of mapping electric lines of force. Now, mapping of electric lines of force gives us a visual picture of electric field up to some extent, because electric field is not visible. So, by mapping electric lines of force, we can at least view the regions where electric field is strong and where the electric field is weak. Since we know where electric lines of force are closely spaced, electric field is strong in that region, and where these are largely spaced, electric field is weak in that region. Okay. Now assignment 1.5. Question number 1. Why two electric lines of force never intersect? Question number 2. Why electric lines of force never terminate in space? Question number 3. How we map electric lines of force? And question number 4. What is the advantage of mapping electric lines of force? So you answer these 4 questions on the basis of the text that you have learnt about electric lines of force. Okay, thank you so much. God bless you.